Yeah, we'll start. Landry, whenever you're ready, you can start.
Hot Stroke Prediction, a machine learning project from the Ledger Zombies. Hi, I'm Landry, and today I'll be talking about the about of our project. So every 40 seconds, someone in the United States has a stroke, and every 4 minutes, someone dies of a stroke. Each year, over 795,000 people in the United States have a stroke, with 1 in 6 deaths from cardiovascular disease being due to stroke. Wouldn't it be great if we were somehow able to predict someone's likelihood of having a stroke and that way reduce the risk? Well, with our project, we can. What is our project? We created a predictive algorithm which receives input data about a user's medical history and general information, then uses machine learning to predict if the user is likely or unlikely to experience a stroke in their lifetime. What is our ultimate goal? Our goal is to warn the user about the likelihood of experiencing a stroke and provide further assistance if necessary. What is our data set? The data set we use is a compilation of some medical conditions and general attributes on an unknown patient, as well as if that patient has suffered from a stroke or not. Is our project classification or regression? Is classification due to the binary nature of our data, stroke or no stroke? What does our MVP look like? Well, our minimum viable product, or MVP for short, is a simple survey format prediction site. But why does all this matter? Well, strokes cause as many as 100,000 deaths each year. If we're able to recognize the possible factors that lead to the onset of a stroke, and if a person is likely to even have a stroke, we could greatly reduce that risk and save lives. With that, I'll be passing it on to Mir.
So now for data cleansing. Well, why is this so important? It is necessary that our data set be prepared and clean before any analysis can be run. So the first step we took in data cleansing was removing columns. Here we removed the residence type and ID columns from our data set, as we believed the data was extraneous and lacked contribution to the final output, as in these columns had very minimal correlation to a stroke based on our data. Then we dealt with null values. As one could guess, real-life data may not always prove accurate. There may be holes which hinder the model training process. We had null values in the mass column, which we then replaced by the mean value. We had a gender labeled as other, and to avoid inconsistencies, we eliminated all its data points. Lastly, we needed to encode categorical data. A machine learning model can only understand numerical data, so the categorical values in our data set needs to be encoded. By encoding categorical data, values are encoded into zeros and ones, and thus can finally be recognized by machine learning models. And now I'll be passing it off to Diego for the next part.
What do we require EDA? Exploratory data analysis involves using statistics and visualizations to analyze and identify trends in data sets, like relationships. Here, we can see the relationship between the age of a patient and their stroke risk. We can see that as their age increases, their probability for a stroke also increases. Here we see the relationship between smoking status and stroke. However, our data suggests that there is no risk with people that smoke and their risk of affecting stroke. This, however, is just because of our unbalanced data set. Even though our data suggests otherwise, we know smoking increases the risk of stroke and heart disease based on medical research. Here we see the relationship between glucose levels and risk of getting stroke, and our data shows that people with higher glucose levels have a higher chance of getting a stroke. Individuals with prior heart disease also have a higher chance of getting a stroke than people who do not have prior heart disease. I'll be passing it over to Shreya.
A machine learning pipeline is a simple way to keep the data pre-processing and modeling code organized in a single line of code. Our first step is data cleaning and feature engineering. We remove the outliers in our data and the ID and residence type columns. Our features include gender, age, hypertension, average glucose level, and BMI. And our target variable is if a person will have a stroke or not. The second step is splitting the data set into training and testing data. 75% of our data is training, and 25% of the data set is used for testing the model. The third step is imputation and encoding, where for the numerical columns, we inputted the mean of the column for the null values, and for categorical columns, we inputted the mode of the column for the null values. Then we one-hot encoded the data set so that all the values are numeric. The fourth step is scaling and oversampling. We scaled our data such that the data was represented in a range of 0 to 1 for faster learning processes for our machine learning models. We also had to oversample our data since initially only 4% of the data set was for people who had had a stroke. The fifth step was using several different machine learning algorithms, such as logistic regression, random forest, and neural network to train the data. The last step was to fine-tune the models using grid search CV. And I'll pass it off to Ryan to talk about the machine learning models.
All right. For our models, we use 3 different models, which were the random forest algorithm, which uses decision trees to create an output, neural network, which mimics the human brain by creating neurons and nodes in order to assign weighted values and create an output, and logistic regression, which uses a logistic curve to classify different data points into either 0 or 1. And for each of our 3 models, we have a subpage that includes different visualizations for the results of our models. And that will include a confusion matrix, a graphical interpretation, as well as our scores. For our scores, we decided to emphasize both the recall and accuracy values of our model, specifically recall, because that would minimize the amount of false negatives that we created, which basically meant that we were minimizing the model's tendency to assign a case with a stroke as a non-stroke case, which would be the most damaging outcome. And in the end, we decided to use the logistic regression model because it had the highest recall value. And with that, I'll pass it off to Brayden for the predictor.
To demo our results, we have created a form where a user can input some medical information and get back a predicted probability of having a stroke. The information we ask for is gender, history of hypertension, average glucose levels, age, BMI, and smoking status, along with a few others. Once the user has pressed predict, the program will give a probability of having a stroke. This output will tell the user if the model believes they're at a low, medium, or high risk of having a stroke. Based on the predicted chances, the model will then provide relevant dynamic resources on how to prevent a stroke based on their risk level. Disclaimer, we are not medical professionals. Our data was gathered from online sources and there can be inaccurate. There are a number of factors that lead to a stroke. If you believe you're at a high chance of having a stroke, seek medical professionals. This is the project that the Electric Zombies have completed over the past 3 weeks.